Welcome to another edition of the Carolina Bay of the Day, where we study the secondary impacts made by the glacier ice boulders that were ejected by an extraterrestrial impact on the Laurentide ice sheet. The Carolina Bays in Marlboro County, South Carolina, provide some excellent examples of bays that overlap while keeping their elliptical geometry. This presentation calculates the energy required to create the bays. The glacier ice impact hypothesis, published in 2017, proposes four mechanisms for the formation of the Carolina Bays. First, a meteorite impact on the Laurentide ice sheet ejected glacier ice boulders in ballistic trajectories. The secondary impacts by the ice boulders liquefied on consolidated ground. Oblique impacts of ice boulders on liquefied ground created inclined conical cavities, and viscous relaxation reduced the depth of the conical cavities to produce shallow elliptical bays. The Carolina Bays in Marlboro County, South Carolina, have a precise elliptical geometry. Since ellipses are conic sections, we can deduce that the Carolina Bays originated as inclined conical cavities. From the width to length ratio of the larger bays, we can estimate that the conical cavities were inclined at 39.7 degrees, which would be the angle of the oblique impacts that created the bays. Many geologists have proposed that the Carolina Bays are the result of wind and water mechanisms, also called Eolian and lacustrine mechanisms. However, experiments of adjacent impacts on a viscous surface produce overlapping features with raised rims that are a good model for the Carolina Bays. If anybody tells you that the Carolina Bays were created by Eolian mechanisms, challenge them to conduct a wind and water experiment to produce overlapping features with raised rims. Stand your ground. Don't let anybody intimidate you into believing that the Carolina Bays are Eolian features without experimental proof. For the Carolina Bay of the Day, I normally discuss only one bay, but because these bays are overlapping, I will analyze the bays in an area of 4 square kilometers. The U.S. Geological Survey has not named these bays, so I have marked them with the letters A through G. Notice that the 4 square kilometers only cover about 1/3 of Bay C, and the small bay on the left bottom corner of the square is not labeled, so our calculations will be approximate. We start with Marlboro County Bay A. Using Google Earth to measure the distance, we find that Marlboro County Bay A is 1,077 kilometers from Saginaw Bay, which is the convergence point of the Carolina Bays and the Nebraska rainwater basins. Assuming that the launch angle is the same as the impact angle, the ballistic equations indicate that the glacier ice boulder that made this bay was launched at a speed of 3.278 kilometers per second. It had a flight time of 7.12 minutes and reached a height of 224 kilometers above the surface of the Earth. The trajectory was a suborbital space flight in the vacuum of space. For this calculation, we assume that the launch speed is equal to the impact velocity, although we know that the velocity was reduced by atmospheric friction during re-entry from the suborbital space flight. We obtained the projectile diameter by dividing the bay length by 5 based on the experimental model. Next, we calculate the volume of the projectile and get its mass by multiplying by the density of ice, which is 917 kilograms per cubic meter. The kinetic energy in joules is then converted to kilotons of TNT, which are easier to comprehend than the joules. The kinetic energy that formed Marlboro County Bay A was equivalent to 12,906 kilotons, or 12.9 megatons of TNT. When we add the energy required to create the Carolina Bays in the 4 square kilometer area, we get a total of 31,794 kilotons or 31.8 megatons of TNT. Dividing by 4, we get an energy of 7.95 megatons per square kilometer. Sometimes people ask me if we could find fossils or evidence of the life that existed before the impacts. With this tremendous bombardment, all the megafauna like the mammoths, short-faced bears, giant armadillos, and all the forest plants would have been ground into a paste. I have shown you a lot of numbers, and perhaps you don't believe them, so we need to get some context. On March 21, 1994, the United States conducted a nuclear blast test. The Sedan explosive device was lowered into a shaft drilled into the desert alluvium 194 meters or 636 feet deep. The blast had a yield equivalent to 104 kilotons of TNT and lifted the dome of Earth 90 meters or 300 feet above the desert floor. The resulting Sedan crater is 100 meters or 330 feet deep with a diameter of about 390 meters or 1,280 feet. The blast caused seismic waves equivalent to an earthquake of 4.75 magnitude on the Richter scale. If we place the Sedan crater next to Marlboro County Bay A, we can see that the Sedan crater is small by comparison. The nuclear crater is just a little bit bigger than the glacier-iced projectile that made Marlboro County Bay A. The Sedan crater, made by a nuclear explosion with a yield of 104 kilotons in the Nevada desert, is slightly bigger than the small bay labeled F. We calculated that Marlboro County Bay F was made by energy of 177 kilotons. This comparison shows that the energy calculated for the formation of the Carolina Bays is in the right range. If the calculation is off, it is perhaps by a factor of 2, but not by an order of magnitude. This means that instead of 8 megatons of TNT per square kilometer, the yield for the emplacement of the Carolina Bays was only 4 megatons per square kilometer. Neither flora nor fauna could have survived the ballistic emplacement of the bays. Study math, physics, and geology. Learn to use the ballistic equations. There's going to be a test, and you better get ready. I will continue to examine the Carolina Bays one bay at a time. Please subscribe to be notified of future videos about the Carolina Bays.